What's up? Hi. So you can consider this my 20-minute long super hot take. Uh, yeah, does school suck? Okay, so I'm a dev intern here at Seven Shifts, so I have no experience really, but I've been to school a lot, which is kind of cool. And I'm going back to school despite the calls for me to drop out. Maybe this is my other hot take. Yeah, so I ask myself a lot, what do I actually use from school? I think this is a question a lot of people ask themselves, maybe. And are there things I wish school had taught me? Are there things I wish it hadn't taught me? Could it have taught me better? So first, let's just talk about what we're going to talk about, which is this program. This is the University of Saskatchewan's 4-year Bachelor of Science in Computer Science. Maybe some of the stuff I'm going to talk about is relevant to other programs, but this is the program I went through, so I'm going to talk about that one. So if you see some of the classes I'm going to talk about, if you're in charge of hiring or something and someone puts these classes on their resume like I did when I applied here, I'm going to give you some context, hopefully, for what actually goes on in those classes. This is going to look like a lot of course numbers, so bear with me. All right, these are your first 2 years of computer science. In first year, you take computer science 141 and 145, so you learn the basics: functions, variables, scoping rules, conditions, iteration, recursion, some basic data structures. And then in 145, you learn more data structures, how to pick them, time analysis, testing, coding, style, abstractions. And first year is just laying a foundation. How do I actually just write and read code in Python? Then you go on to second year. You take CompSci 214, which is like tooling, scripting languages, basic operating system content, how to be comfortable using system utilities, libraries, using the shell to do stuff. Computer Science 215, how the CPU works, how a computer actually does math really quickly. Computer Science 260, all the math you need to know. Discrete math, number sets, logic, proofs. Computer Science 270, developing object-oriented systems, modeling problems with objects, design patterns, unit testing. Computer Science 280, you talk about graphs and path algorithms and all those famous things like Dijkstra's algorithm, stuff like that. So second year is still laying a foundation of concepts that are going to build towards building larger systems. One class in particular I want to dive into here is Computer Science 270. Most of us probably use object-oriented programming. So these are some snippets from the curriculum for this course. So the top one is the course catalog, curriculum objective. So using modeling, abstractions, blah, 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 building a GUI, unit testing to ensure system meets requirements. It sounds pretty good. Application of techniques to interactive systems. The bottom here is from the syllabus of a recent offering of this course. The two I want to highlight here, the bottom two. So learn the techniques of unit testing and learn the basic principles of designing and building a large software system. Let's talk about the unit testing in this class. So I used to be a TA for this class. I've TA'd this class twice, and I took it back in the day. So I'm going to show you guys some solution material for this course. Please do not share it with your fellow students. All right, this is a unit test in this course. So this is not done with any sort of framework. We're not using JUnit or something here to run these tests. They all have to be written manually, and it's expected that you write them manually. So the top bit here is one of the tests, and then this second chunk is a second test. And this is just testing the main project that you do in this course. So the way this course is structured is you do 2 quick assignments on let's learn a bit of Java, because you just did a bunch of Python in first year, and Java has types and it's compiled, and that might be weird to you. So the first two assignments are just getting used to that. The rest of the class is structured around 4 assignments that you build on. So you're working on the same system, designed objects in an object-oriented way, and you just iterated on it over those 4 assignments. It's usually a version of a hotel system where people get assigned to beds, and you have to track the managers of the hotel and the people who are staying at the hotel and which beds they're assigned to and other support staff for this hotel. Then every year they just put a different coat of paint on it. So the years that I was a TA for this course, it was a hospital and it was a vet clinic. And then in the year after I stopped TAing it, they made it like a residence system, like a university residence, assign students to beds and have RAs and stuff like that. That's what this material is from. So basically, these tests are checking, the top one's checking if I assign someone to a bed, that these other beds should be available still. And the bottom one is actually testing the toString function. So there's this big, huge, disgusting concatenation that they're like using to make the assertion. So yeah, I mean, I think some aspects of this are good, like forcing students to grapple with how they ensure their software is working is a good idea, and testing is obviously important. But this is also not super close to what testing looks like, at least in my experience. We're not using any like mocks or spies or stubs, and like tests usually aren't this simple in my experience. And there's not like advanced topics, I guess, covered, which is fine. It's a 200 level course. But I'm here to tell you this is about as intense as it gets. There's not like a future class that builds on these concepts to teach you how to scale up your tests and write more complicated kinds of tests. This is kind of like the check mark that they put in the curriculum that, yeah, we talked about unit testing. That's great. A big challenge I had starting on my internship position here was learning how to use unit test frameworks and take advantage of the kinds of features they had to like help you ensure that your code is good, except for front-end tests. I still don't really know how to do those, so I just avoid writing them. So what I'm getting at here is the curriculum lies a little bit, maybe, just because like a bunch of classes might say that they teach you unit testing doesn't mean that those concepts are like carried through and like teaching you something holistic. So yeah, it's a skill that you learn somewhat by doing this, but I didn't really find myself prepared for it in the workforce. Okay, so moving on to some 300 level courses. So these 6 courses, these are like the bulk of the degree. In your third year, you have to take 6 of these 7, and these determine what 400 level classes, which is this bottom requirement here, you have to take. And this is where you start to specialize a little bit. And this is also like, I like to see these 7 courses as like what the university thinks a computer scientist should probably know. So I'll just walk through these really quickly. Computer Science 317 is like basic AI stuff, super basic theory, knowledge representation, some basic reasoning and searching, playing games, and like basic machine learning techniques. Computer Science 332, operating systems, concepts, how the computer works, I guess, how processes get scheduled, virtual memory. Computer Science 340, functional programming, everyone's favorite, recursion, higher order functions, logic programming. Computer Science 353, which I'll talk about a lot more in a sec. This is like web programming, client server, HTML, JavaScript, web developer stuff. Computer Science 360, another math class, theory, algorithms and theoretical computer models. Computer Science 370, software engineering. This one is like how to organize work. It's not really teaching you like, there's not a project that you do that's like facilitated as like, this is like a hotel system. You get to pick a project to do, but the course content is like software engineering, academic research, like Scrum is good and builds effective software, and testing is economical and you should do it, that kind of stuff. And then Computer Science 381, how to build UIs, techniques for building interactive software, psychology and art and design are kind of melded into this class a little bit as needed. Yeah, so I want to dive into particular two courses here. One course that I really like, and I think if you see it on someone's resume, you should take that very highly. And one course that is an attempt at the university doing better that falls incredibly, incredibly flat. So these are the 2 courses. Computer Science 353 is a course maybe a lot of people that I've talked to at work don't know about. It's a new course. So they used to have Computer Science 355, which was like a databases course, and a Computer Science 350, which was a web development course. I might be mixing up the numbers. Regardless, they had a web course and a databases course, and they decided for some reason to merge them into one big course and call it full stack web development, and then stuff it to the brim with all the stuff that people do in industry apparently, like use Docker and Node and React and SQL and all these things. I can say we talked about the things on the left there and all these technologies, but I can't say that any significant depth was covered in these courses. And I think this is the perfect example of a kind of course that didn't actually translate into any real job skills for me, even though these things on the left look really relevant. The course was just so full of stuff. It's trying to teach you like stuff a developer should know that it didn't actually teach any foundational skills. Like, why would I pick React over something else? Why would I pick a certain programming paradigm or not? And what the difference between databases are, really even what like databases or relational data is. Not I couldn't even say this course teaches you, how anything works, or barely even what it is. But the class on the right, however, Computer Science 370, this is a great class. Instead of trying to teach a bunch of industry relevant tech, we just learned how to organize software projects. So like using some of these tools on the right to make working in a team of 5+ people easier, and how to decide what to work on and prioritize that work and split up that work, which sounds a lot more like what the job actually is. This class even involved a project where you could work with a real stakeholder and build something for somebody. The class trusted you to write code on your own and let the course content be about all this other content you might know, like all the research about what kind of software methodologies are effective. So yeah, what is bad about 353 again is it's trying to teach you a bunch of stuff a developer should know. So Computer Science 370 is taught by Zadia Kodabu. She's really good. I hope she teaches more classes. So yeah, what's the problem, I guess, with 353 and other classes kind of like it? It's like a big list of stuff you should know. So this picture on the right, some of you might have seen something like this. It's a developer roadmap. They're kind of interesting. They're supposed to be like you follow them down, and it's like you learn all these things. So if like I want to make my goal to be a front end developer, I start at the top and work my way down and like learn all these things. And the different colored check marks are supposed to be like how relevant they are. So the purple check mark with React is like you should learn React, but then the green check mark with Angular is like maybe don't learn Angular, but it's still good. But I think like the problem with like approaching teaching and learning like this is that you're not, again, there's no like foundational theory about like why, like what problem was React trying to solve. It's just learn React because it's like what people use and because you can become a guy who knows React and get hired to do React. But like what is React actually trying to do and why you should use it isn't something that you think about or learn when you like approach learning this way. And I think that's the flaw with the way Computer Science 353 is taught, because it's not approaching it from that foundational perspective. I think another issue too is putting too many projects and putting too many pieces of a tech stack into a class and then just having a bunch of assignments where you're like, yeah, I did Docker, check mark, move on to the next thing. You're not actually applying those things to a project that you have to maintain over time. So these skills that you might even learn, even if you're not thinking about foundational skills, like working with React over like 3+ months, you will get better at it and start to see those patterns and what's useful about it. But because there's not a project to guide you through those things and force you to grapple with decisions you made earlier, you never actually end up learning those things. So shallow assignments are bad, basically, and projects are really good. But what other things make a course really good? So in my eyes, if you're someone in the room who teaches computer science, this is like my student perspective on some things that make a great course. So first, projects as a way to evaluate. So I think evaluation, this is, I guess, my hot take for education. Evaluation should entirely be based on projects. Like, I think a big thing with assignments I find frustrating is that they serve to demonstrate like an immediate concept and a mechanic of some maybe programming language concept. Individual assignments can show that you maybe have a grasp of like lambda calculus or something, but a longer term project shows you can take concepts and apply them to novel problems. My one caveat here is I think classes can have assignments, but they can structure themselves in a sort of like way where you're building upon them or using concepts and applying for the next thing. I think the issue is classes with a bunch of isolated assignments that again are just serving as a checklist of like, okay, did this, move on to the next thing. The other thing here too is I think running a class only based on projects is like maybe an administrative nightmare, so I get why not every class is like this. Okay, next, principles. I think the focus should be on principles rather than specific technologies, but technologies and a specific tech stack can serve as like a medium for demonstrating those concepts. So rather than a class that's supposed to teach me Docker, I would like a class, for example, that is trying to teach me containerization, and Docker is just like the medium by which I learn containerization. And that gives me more context for why that technology is useful. Next, I think a lot of my favorite classes had like flipped classroom self-learning style teaching. So for those who aren't familiar with the flipped classroom, it's essentially shifting the burden of the initial absorption of the material to the student's study time, and the lecture time is dedicated to like open group discussions or working on problems in a collaborative setting with students and the professor there as like a facilitator. in particular, the Computer Science 317 Intro to AI course is structured like this. So you do the readings on your own time, and the lecture content is, let's talk about this problem, and you guys can propose solutions to the problem. And I, as the professor who has studied artificial intelligence for 10 years, can talk about why that approach is maybe good or bad, and then the assignments serve to solidify that understanding later. As a student, I really like classes like this because lectures that are just there to deliver me content are kind of pointless because I could just do that reading or watch a video or something on my own time. And lastly, modernity is good. I think keeping the tech stack, which again should be a medium for understanding principles, at least somewhat modern, is important. I think it's really frustrating when you're working with like compiler level C and working with a library that doesn't have documentation that was written before like there was even an ANSI standard or something like that is really annoying. Again, the tech stack should be a medium for the principles, and I don't think this needs to be like cutting edge. Like I think there's also a drawback to teaching the most like recent developments, but I like classes that are at least teaching me skills that kind of have been invented in the past 10 years and are like somewhat relevant. Okay, yeah, so what I want to do next, these are what I think is good for a course. So I just want to dive back into these courses and just talk about them a little more to close it off here. Yes, the one class I want to talk about here is the Programming Language Paradigms course, because I actually haven't taken it, but I've taken the other 6. Okay, so the Intro to AI course, like I said, this is a flipped classroom course. Not project-based. The assignments are pretty good, however, regardless. Emphasis on principles and theory, apply those to assignments. Some of the stuff you do in this class, like you build an agent that plays like simple chess. Like in my year, it was like Mega Man chess, which is like had modified rules from normal chess. But you build like an actual search algorithm that like plays the game. You do some analysis of performance of various search techniques over games and things like that. And you do some basic machine learning techniques. Nothing really like neural networks or deep learning or anything like that, but like learning about machine learning, what it is, what it's trying to do. Operating systems concepts, like super notorious course. And what I will say about this is if you've taken it in the past like 20 years, it has not changed. It's the exact same class. But I think this class could be really cool. It's basically working with big software. You're working with a big code base. A toy operating system called XV6, and you're making modifications to it, and you're trying to learn how it works, and that like is a pretty good analog for what development actually kind of looks like. I think this course suffers in the modernity category, I guess, and I think it's too much work, and it just kind of absorbs the rest of the courses. So you're just like, if you ever take this class, you're just like solely focused on it, which kind of sucks. But in principle, it could be cool because you're doing a pretty good simulation of what software development looks like. Okay, I talked about this course a bunch already, but I really don't like this course, and I actively encourage people not to take it. I wish it taught the things that it's claiming to teach, but it doesn't. I wish I could say this course even like exposed me to JavaScript or something, like something I hadn't seen before in my first 2 years, but it really didn't. Like the content is just so vapid that you don't learn anything. Like I mentioned before, Ralph Dieters teaches this course. It's a bit of an administrative mess. I think part of that's because it's new. It's like 3 years old. But yeah, every year it's been taught, it's had like organized student complaint, like not just people writing letters to the department, like the Computer Science Student Society is like getting together and doing something. So yeah, this course is like, I guess what I'm trying to get at here is like, there is a project and like, it looks good on paper, but I would like treat it with a grain of salt, at least for the immediate future. If you're like seeing this on someone's resume, at least I would if I was in charge of hiring. Yeah, Computer Science 360, Machines and Algorithms. This isn't just a theory class. I think it belongs in the degree personally. This is like teaching you some fundamental things about computer science theory and like maybe teaching you how to be a theoretician. And I think that's all good. This isn't a class that's going to give you any sort of like thing to put on a resume. It's not going to give you a project, but it's like a good theory class that flexes problem solving muscles. And that's really good. I think that's good. But all you really do is prove theorems. So if you like proving theorems like me, it's awesome. But if you're not a theory person, then it's kind of dry. Computer Science 370, discussed this earlier as well. Emphasizing project work. Pretty much the whole grade for this course is like how you did on the project, broken down by like how well you organized it and like your check-in steps. And it encourages you to work in like sort of an agile Scrum environment. So you have like you do sprints and organize them into tickets and like estimate them and all this stuff like that. So it's good for. I was really comfortable with that system coming into work, which was awesome. And working on a long-term project with real stakeholders that I had to maintain was kind of cool. And the class itself had lots of guest lectures from people in industry, which was really cool. Like no other course I had taken had done that before, and that was really awesome. Lastly, Computer Science 381. This one is probably one of the best lecture content courses, but the actual assignments are kind of just like working with like a Java GUI library, and I felt like that part didn't apply. But the other half of the assignments was like doing user research and doing things like defining user personas and things like that. So like some of it was like non-coding aspects of design work, which some people might find interesting. I think our interactive systems design program could emphasize more of this content, but it's kind of in a weird state right now. But yeah, this program could be better, could have a project, but it's pretty solid in terms of course content, but nothing, again, this is a class where I wouldn't really put much from this on like a resume necessarily, but there's some good theory from this course. So yeah, I think learning shouldn't be a big checklist of stuff you should know, or at least stuff that I could just learn on my own relatively simply. I think any knowledge gaps that students are experiencing coming into the workforce isn't going to be stalled by putting a bunch of modern tech stack brand names into a course. But the theory to practice bridge is hard to gap. There's lots of research in the world of education about how to do this effectively, but it's hard to implement. Flipped classrooms aren't very common because they're quite expensive to do, and people don't have resources to do that kind of thing, even though in theory it's really good. But yeah, hopefully you're more aware of what the U of S program looks like now. And yeah, if you have any questions or whatever, hit me up. Yes. A little bit, yes. A little bit. Oh, sorry. The question was, is school overrated? I think a little bit. If your goal is like, I want to go into industry as quick as possible, like don't go to the U of S. But if your goal is to like expose yourself to theory or maybe do some interdisciplinary stuff with like, I want to take a bunch of weird, I don't know, philosophy and economics courses or something, then like definitely go to university. But I think if your goal is to be a software developer and you're starting from ground zero, like don't do it, basically. Yeah.